There are a number of common mechanisms by which a piece of malware might spread onto a given system, and those include things like spreading via USB devices or spreading over email, for example, with email attachments, although that's a less common technique nowadays, malicious URLs, and so on and so forth. There is, however, one relatively recent newcomer to this list, and I thought I would describe that approach to you, and that is what we call spreading onto different virtual machines. Virtual machines. Okay. And we actually have started to see a number of instances of malware leveraging this type of technique. And I do want to stress, though, that it's not a particularly prevalent technique at the moment. But whenever a new piece of malware or new malware design technique, for that matter, is developed, we do start to see more and more instances of it, especially since really the bar has been lowered, effectively lowered for malware authors. And now subsequent malware authors can leverage the efforts of their predecessors and really avoid having to reinvent the wheel from scratch. And I think that actually causes an uptick in terms of new techniques that do get deployed. Now, one example of a piece of malware that actually spreads onto VM instances is something called Crisis. And it's also been known, it's also been called Morecut, so you might see that name as well in various descriptions of it. And really, the malware itself, I do want to mention, it's a Trojan, which means it's a standalone piece of malware, and it does a lot of the same things that a typical piece of malware might do. In fact, the way that it typically will get onto a system, the most common mechanism, is via social engineering. Okay, so it actually tries to trick a user into installing the malicious file, and it hopes that it can trick a user through an appropriate level of social engineering. And the thing is, once it's on the system, and it does a lot of the standard things that a typical piece of malware might do, like it'll try to steal information, it'll create backdoors, and so on and so forth. I don't want to focus on some of those applications. I do want to focus on one particular aspect of it, which I think is really noteworthy, which is that Crisis actually tries to find instances of VMware images. So it searches for VMware instances, in particular images. So, and I think this is again pretty new. And I do want to, maybe I should take a step back here and let's think about this for a moment. When you think about it, let's say you've got a physical machine. So here you have a physical machine. Okay, at the end of the day, what is a VMware instance? Well, you will have, to start with, on a physical machine, you'll have kind of a hardware layer at the very bottom. Okay, and that'll include things like a floppy drive and a hard drive and memory and a CPU and so on. And then typically on top of the hardware layer, depending on how abstract you want to get, you typically will have an operating system. And the operating system might manage the file system for that computer. And then you'll have applications that run on top of that. And really, one of the applications would be a hypervisor. Okay, and what is an actual image? Well, let's say you've got you have typically the way I like to think about VMware images and really virtual machine images in general is that they're basically just a file or maybe a set of files that are located on your file system. So, for example, you might have a file that's located on the file system, and maybe it'll be called, let's give it a name, like, how about my image. Okay, and let's give it an extension. And so if it's VMware, the extension would be VMX, so this would be a VMware image. And obviously there's an instantiation of this image somewhere in hardware. There's maybe a set of bytes on your hard disk that represent this particular file. And then this file can be accessed by other applications via the file system. Okay, and what does that mean? So when the file itself, really at the end of the day, a VMware image basically just encodes information about a standalone computer system. So, for example, within this image, and maybe we'll kind of draw this out here so we can see maybe it's a file. Okay, and this file will have information about, let's say, a CPU, and it's going to have information about a hard drive. And these are not real hard drives or real CPUs, but these are kind of virtualized instances. They're just basically encodings of information. It'll have information about an OS and applications and really anything you can imagine on a computer. Okay, and then the idea is that this particular image, this image is going to be loaded into a software application that can interpret it. So, for example, if we're talking about VMware, well, VMware has something called a VMware player, so you might have a player application. Okay, and the player will basically load my image, the file my image .vmx, and then it'll know how to interpret the contents of that file. Okay, so when you load an image into the player, then within the image, or within the window rather, of the player, you'll actually see an emulation of an actual system running. Okay, but at the end of the day, the most important thing is that the image itself, the image is basically just a file, and that file can theoretically be modified to include really an encoding of a copy of the Crysis malware, which is effectively what Crysis does. And so what Crysis will actually do is it does, I guess, a series of steps. I mean, the first big step in Crysis is to basically find VMware images, which I labeled out here, so let's mark that as 1. Once it finds those images, it'll basically mount the image, okay? And after mounting the image, it then will just copy itself onto the image. So it basically makes a copy of itself onto the image. Okay, so the idea is that really, when we talk about copying yourself onto an image, all it's basically doing is it's now finding this image from myimage.vmx, and it's going to basically add, there's a bunch of applications. It can now kind of add itself as an application inside that image. It'll basically modify that file, essentially modify that file. It might also, for example, add itself, if you have an operating system and there's configurations, it might add itself to the startup folder of that operating system. So at the end of the day, when the image is loaded, the malicious application is then run. Okay. Now, one thing I do want to emphasize here is that there is no security vulnerability in VMware that Crysis is exploiting. I mean, the reality is that being able to copy a file into a VM image is a very standard operation, and there are many, many legitimate reasons why you'd want to do that. For example, it'll allow you to programmatically manage a large number of VMs. And if you imagine, if you have enterprise IT administrators, they may want to, let's say, update a configuration file on a large number of VM instances, and they might want to be able to do so without having to actually replace the entire image. And therefore, it's useful for them to have functionality that allows them to modify maybe a particular aspect of an image, basically adding a file to an image, and to be able to do that programmatically rather than kind of manually. And so functionality in general for managing files within VMs, it's been available for a long time. For example, VMware in particular, VMware offers functionality. I think they had an API that was called the VIX API. The VIX API, although I think nowadays the VIX API has been incorporated into something called the vSphere API. So vSphere. Okay, and really what these APIs allow you to do is manipulate the internal contents of a VMware image, among other things. Okay, and so this is a fairly standard game, and it's not, there's no exploit that's being taken advantage of. Now, I think I do want to mention actually one more noteworthy aspect of this particular malware is that it is, interestingly enough and somewhat ironically, it's antithetical to another technique that malware authors have used in the past, and that is that many malware instances will try to detect if they are running inside of a virtual machine instance, and if so, they actually will either stop running or will do some fairly benign things, and you might wonder why that's the case, and the reason for it is that security researchers often run malware inside of virtualized environments, and so it's in the best interest, I guess, of malware to behave differently, or for that matter, to behave benignly, if it thinks it's being observed by a researcher. Okay? And so for that reason, a lot of malware will act differently when it's inside of a virtual machine instance because it thinks it's being observed. Now, what's interesting is that Crysis, in the case of Crysis, it's not actually shying away from virtual machines. In fact, it's seeking them out and it's infiltrating them directly. And as I mentioned earlier, I do want to again emphasize that this particular malware design technique, it's fairly new. It's not very prevalent right now. It's not very common. But I do think it's one more tool that's in the arsenal, if you will, of a malware author, and I think time will tell if it becomes a more popular technique, and I have to imagine it will be because there's so many people out there that are using virtual machines to help manage large back offices and large data centers.